computer A can process a data set in 10 minutes. Computer B can process the same data set in 15 minutes. Computer A starts processing alone. After 4 minutes, it overheats and stops. Computer B is then turned on to finish the job. How long does computer B work? Now, this question is different from the ones we've solved so far. So let's make sure we understand it. Here, the two computers are not working at the same time. Computer A works first, and after it stops, computer B finishes the remaining part of the job. Because of this, we are going to move away from using the table method or the shortcut method. We used those methods when both workers were working together at the same time, and their rates could be added. So, to solve this question, we are going to use the idea of the total work done. That is, total work done equals the work done by computer A, WA, plus the work done by computer B, WB. Remember we said earlier that work equals rate times time. So, using this formula, the work done by computer A will be its rate RA times its time TA. Similarly, the work done by computer B will be its rate RB times its time TB. If we substitute these two formulas into the first one, we'll have the total work done by both computers equal RA times TA plus RB times TB. This is the formula for the total work done, and we can use it to answer the question. So, from the question, the work or job being done is processing one data set. Therefore, the work or job being done is just one. Next, let's find the rate of each computer. We said earlier that the rate of each worker equals the work or job being done over the time it takes for that worker to complete the job alone. Computer A can finish the whole job in 10 minutes, so its rate is 1/10. Next, computer B can finish the same job in 15 minutes, so its rate is 1/15. Also, according to the problem, computer A works for 4 minutes before it stops. So, TA equals 4. However, we don't know how long computer B takes to complete the work, which is what the question asks us to find. Now, we can substitute these values into the total work done formula. So, we have 1 equals 1/10 times 4, plus 1/15 times TB. 1/10 times 4 is 4/10, and 4/10 simplifies to 2/5. So, we have 1 equals 2/5, plus 1/15 times TB. Here, the 2/5 represents the portion of the job that computer A finishes before stopping, which means the rest of the job is still left to be done. Next, to find the time it takes for computer B to finish the job, we must make TB the subject of the equation. First, we'll subtract the 2/5 from both sides of the equation. The 2/5 on the right side cancel out. Next, we have 1 minus 2/5, which gives 3/5. So, we have 3/5 equals 1/15 times TB. The 3/5 represents the part of the job that computer B must finish. Next, 1/15 times TB is the same as TB divided by 15. So we'll multiply both sides of the equation by 15. The 15s on the right side cancel out. Next, 15 times 3 is 45, and 45 divided by 5 is 9. So, TB equals 9 minutes. Therefore, it will take computer B 9 minutes to complete the remaining work.